discuss why things float. What is buoyancy? What is this upthrust? What is Archimedes' principle? And we are going to learn these principles and we are going to also apply them, and you will be seeing the most interesting thing, which is why do exactly ships float even during rough seas? You might think that you know the answer, but let me tell you, you're going to see a big revelation today. So hold on, and you are going to see some amazing problems, some amazing concepts, and we are going to go much higher than what you would have studied probably in your 9th or 10th grade. And we are also going to explain why things float or why things sink. So if you are wondering why does an alligator or why does a crocodile float, so don't worry, I'm going to explain that. And it's nice to see a crocodile floating unless and until it starts doing this. And I'm pretty sure nobody would like a crocodile in motion on land doing this. Alright, okay. So this is Shreyas here, guys, your master teacher going live, and I'm your physics anchor out here, your physics master teacher on your very own channel, JEE Enthuse. I also take all batches on our regular platform, on the app, on the website, and I take up a lot of micro courses. So I've been mentoring, I've been training a lot of kids for IITs, for NITs, for BITs, for Olympiads, you name it. And a lot of my students currently are in the topmost prestigious institutes in our country. And I myself cleared my IT entrance examination a long time back, and I feel that I should definitely train kids with the knowledge that I have. So that's why I'm here. I love teaching and I love physics. And guys, if you want to still get in touch with me, you can of course do that. I have shared my Instagram handle, that is Shreyas_Vedantu. So you can ping me over there, and also I put up some amazing questions, amazing videos, motivational quotes, and a lot of other things on my Instagram handle. So do check it out, it's fun. And today itself I have posted one question and a lot of people have given the wrong answer. Anyways, I'll be revealing the correct answer in tomorrow's video. Alright, so welcome aboard Jumna, Kirito, Ranjit, Aarthi, Science Priya, Dinesh, Ashwat, Ankit, Satish. Welcome Pranati, Uncharted, The Holy. Welcome aboard. You guys are so cool. You guys are so amazing, and most of you are regular students. Now probably I don't even have to look at the chats. It's just like, you know, there in my head. Okay, all these students are always there. So that's how it is. So welcome aboard. Hi Vaya. Hi Gaming. Welcome aboard. A lot of new people as well joining in. So guys, let me also tell you, if you are not yet a member of our family, you can become the member of our family by hitting the subscribe button out there. So just go hit the subscribe button. You will be getting all the updates, important videos, notifications, and lot of important revelations which are going to come up for your board examinations and JEE Mains as well as advanced. And if you're already subscribed, you know what to do. The usual drill, guys. You have to smash that like button out there. Come on, go ahead and smash the like button, because unless and until you smash the like button, YouTube is not going to recommend you our videos, and I'm not going to get that energy. So go ahead, hit that like button out there. Okay, now let me also tell you where we are right now. So we are in Fluid Mechanics Lecture 2, and today we are going to talk about flotation, buoyancy, and some really cool problems which are coming at the end. So stay tuned. You will be seeing some important revelations which are going to be made in the end, and also the homework question, and also the stars of the previous to previous session. You will see what the stars of the previous to previous session is after some time. Tomorrow we are going to do fluid dynamics, and Thursday, Friday will be starting capacitors, lecture 1, lecture 2. The week after that, lecture 3, lecture 4 of capacitors, and Saturday it's going to be a special session. You can keep guessing what it is, but it's going to be a special session. All right, so let's get going, guys. And before we move ahead, let me make you see this, guys. A very important announcement. On Thursday, the current electricity Menti quiz is not going to be at 11, it's going to be at 8 AM only for this week. The current electricity Menti quiz is going to be conducted at 8 AM. Please keep this in mind. Okay, morning 8 o'clock physics Menti quiz Thursday, that's day after tomorrow, on current electricity. Chemistry will be on Saturday, maths was conducted today itself. All right, so please note down these timings. This is very important. That's the schedule for the week. So let's get going, and let's now start talking about what is Archimedes principle. Now, before we talk about Archimedes principle, let me tell you, we need to understand a very important concept called as volume displaced, or what is the displaced fluid. Now, what is the meaning of displaced fluid? You would have experienced this, let's say when you are having bath and you put your hand inside water, right, in that bucket. So you will see some amount of water comes up or some amount of water gets spilled. So that spilled water or that extra water or that extra fluid is called as the displaced fluid. And this is what Archimedes understood many years back, thousands of years back, okay? And basically the story goes something like this. I don't know how many of you know that story. The story goes something like this. The king wanted to check whether the crown was real or not, whether the goldsmith had mixed some brass or some other metals inside it. So he gave this like an open challenge, and Archimedes, he was having bath, and then he suddenly understood that, okay, you know, I am feeling kind of weightless when I'm sitting in my bathtub, and maybe there is an upward buoyant force kind of a thing on me, and maybe using this I can figure out if that crown is real or not, because if it was made of pure gold, then it would weigh differently, and if it was mixed with something else, then it would weigh differently. So that's what struck his mind, and he forgot that he was not wearing clothes, and he ran out of the bathtub, you know, whatever, and he claimed eureka, eureka, eureka. So that's the story, guys. Yes, Pranuti, yes, Krito Saurav. All right. Yes, Ankit, by the way, I will be going live on Instagram in a day or two. I'll be telling you the exact time very soon, but I'll be going live on Instagram like a casual interaction, but on a specific topic. You will see what is that topic. Yes, don't worry, Ankit. I'm listening to everyone. Okay. So, this is what happened. Look at Archimedes. See what is happening. He was in his bathtub and he sat in that bathtub. He saw that whatever part of his body was inside the bathtub, exactly that much amount of water spilled across that bathtub. You can see that. So whatever is the volume inside a fluid is the volume which spills or comes out, or it comes up in that container. That is called as the displaced fluid. I hope this is very clear. So this principle can be in fact used to find the volume of any random shaped object. So something like a stone. Imagine you take a beaker. I'm pretty sure you would have done this experiment, and if you have not done it, you can still do it at home, guys. Just take a beaker, fill it with liquid, let's say water or anything. Oil also will do, by the way, and check out the reading. Now put that stone or that random object inside that beaker, let it be completely immersed, something like this. You will see the level of liquid will come up. So whatever is that extra volume, that volume is the volume of the stone. You don't need integration, you don't need any formulas. Directly you can figure out the volume of any random geometry. So this is the meaning of displaced fluid or displaced volume. So that extra volume is called as the displaced volume. So I can also say the volume of solid submerged, the part of the solid which is inside the liquid, submerged, is called as displaced fluid. Okay, so this is called as displaced fluid. So understand, if the solid is not completely immersed, and if it is something like this, then this much is the volume of the solid which is submerged, and this will be exactly the volume of fluid which will be displaced. Remember that. Is that clear? Everyone understanding this? Is everybody understanding this? Aishwarya, you're not late. Don't worry. I've just started explaining few things. I've just started with volume displaced and all that. Amazing. No problem, VK channel. I'm glad that you are much earlier than yesterday. All right. Very good, Ankit. Glad to know that this Menti time is suitable. Okay. So now let's do a question. I'm going to give you a very fascinating question, and the question is like this: how much approximate volume of air? Okay, now before telling you this question, I have a very interesting thought that just popped up my mind, guys. This is very scary, at the same time it's very fascinating. Okay, now when you look at a fish underwater or a tortoise underwater, you'll be like, yes, it is submerged inside liquid like water. So you are outside that water. You are not submerged inside the water. You are a land animal. Now think about it. Actually speaking, even you are submerged, but not in water, but in air. And you know how deep you are inside air? You are around 300 to 400 kilometers deep inside the air. Yes, the surface of air is where the ionosphere ends. And you are seeing that the layer of atmosphere is around 300 to 400 kilometers. So actually you are 300 to 400 kilometers inside that ocean of air. Isn't it interesting? Yeah, for the fish and even for the aliens and anything in the space, we are submerged. We are that so-called air aquatic animals for the other things. Interesting. Yeah. Interesting, scary, as well as fascinating at the same time. So don't you think we are displacing air right now? Yes, I'm submerged, so I'm displacing air right now. Correct? Isn't it? And that's what the next question is. So what approximate volume of air does a pandu of mass 50 kg displace in liters? Make suitable assumptions. So this is our pandu, a very cool yo-yo type of pandu. And let's see how much volume does pandu displace, guys. So let's look at it. Now make assumptions. That's what it says. Everybody knows that pandus, that is us, can almost float in water. Yes, I'm pretty sure you would have seen that we float in water if we don't do anything. Hardly our nose and our eyes just come out, hardly a bit. And plus, our body is 80% water. 20% is those remaining things. But even those 20% things, the density is approximately, on an average, the same as the density of water. If we were more dense than water, then we would have sunk. So think about it. Can I make this fair assumption saying that the density of pandu, now rho is the symbol for density, density of pandu, can I say it is approximately equal to the density of water? Is that a very fair assumption? Everybody agrees with this fair assumption? Yes, pandu is in chill mode. Yes, VK channel, do you remember that song, Coconut mein lassi mila ke, aajao sare mood bana ke? Yes. So Devendra, think about it, 80% of us is water, plus when you jump into a pool, you almost float. You almost float. So you are neither sinking nor completely out like a wooden block. So your density and water's density will be approximately same. I hope this is clear. Yes. Alright. So now if your density and the water's density is approximately the same, what is the density of water? The density of water is 1000 kg per meter cube. Okay. But what is density? Density is nothing but mass of pandu divided by volume of pandu. So therefore, can I not say that the volume of pandu is mass of pandu? How much is it? 50 kg pandu we have. 50 kg divided by that density will come down here. This will be 1000 kg per meter cube. Now take it upstairs. It will become 50 into 10 to the power minus 3 meter cube. That is what my volume will be, but that's in meter cube. Beware, the question is find it in liters. Now you should know these conversions, guys. Remember, 1 ml is 1 centimeter cube. 1 liter is 1000 ml, and therefore it will be 10 to the power 3, okay, 10 to the power 3 centimeter cube, which is the same as, think about it, 1 centimeter is 10 to the power minus 2 meters. So 10 to the power 3 into 10 to the power minus 6 meter cube. So 1 liter is nothing but 10 to the power minus 3 meter cube. Look at that. 1 liter is how many meter cube? 10 to the power minus 3 meter cube. If that is the conversion, think about it. How many liters will this be? So just forget that 10 to the power minus 3 meter cube. Just put it as liters. It will be 50 liters. So this is the volume of pandu. This is the volume of pandu. Guys, this was an interview question in KVPY. You know what one guy did? This question was asked, "Ki, what is your mass?" He said, "Sir, my mass is 45 kg or some 50 kg. And then he was asked, "What is your volume?" Then he started scratching his head, and he had clearly not studied under me. And then he's like, "Yes, yes, I know what to do. I need to use Archimedes principle. Please provide me a bucket of water or a tub. I'll jump and I will figure out my volume." That examiner banged his head. He's like, "Chullu var pani mein doob jao. Just jump in that small bucket of water." Guys, you don't need to jump. Yes, you don't need to jump inside that bucket of water to actually calculate the volume, because you know your density is same as the density of water approximately. So the question was to trick you and to find out whether you can use common sense. That's all. Yes, understood, guys? What an amazing question this was. Yes, Princey, I agree with you. All right. Let's get going to the next question, guys. Let's get going to the next question. Yes, Uncharted, you should be really thankful. Now, before we go to the next question, which is going to be about upthrust, what is this buoyant force and how does it come? Why does it come? What is this exactly? I'm going to give you all the details. Hold on. But before that, let me tell you guys the Vedantu Pro subscription, which covers all the needs that you have. Like some students want to study for KVPY, some students want to study for crash course, some students want a special course, let's say for a booklet discussion, some students want test series, some students want the assignments, some students want, you know, the booklets and so many other things. So now what happens usually is you end up joining multiple classes. For physics you join this class, for KVPY you attend this class, for test series you join another coaching, and then for, let's say, chemistry you join another class. But in Vedantu Pro you don't have to have that headache of joining multiple classes. Everything is under one roof, under one price. It's like your Netflix or Amazon subscription, and everything is free under this subscription, no matter how many courses you join. And the best part is you get your regular batches, and other things are all extras. Regular batches there. And apart from that, if you want Olympiads, no problem. If you want boards, no problem. If you want extra booklet discussion, no problem. In that regular batch, you have test series, discussions of those tests, assignments, and then you get report cards where you can check how you have performed. You can check question by question analysis. And then you have the option of learning in English and Hindi both, and so many micro courses. So guys, understand you're not just getting all these extra things, but apart from that, you are saving a lot of your time and energy and money. That's very important. And if you can see the prices, let's say you take up 3-month subscription, which actually costs around 13,500. Now, because you are attending my YouTube session, I will be giving you 20% off. And the 20% off works out to be something like this, 10,800. That's for the next 3 months. All right. And you can see per day cost is 120 rupees. That's hardly anything. And if you want to take it for the next 1 year, that's even better. The prices come down even further. The 42,000 course price comes down to 33,600 rupees. It's much lesser. I think some classes charge 10 times of this price for 1 year. Yes, believe me. Some coaching classes have fees of 3 lakh rupees, 2.5 lakh rupees per year. It's 10 times the price. And look at the price you are getting after a discount of 20%. If you work out the price, it's 93 rupees per day. And absolute loot happens in these coaching classes because they don't cover all these things, and it's not a holistic approach, and you don't get trained for KVPY and all these things. So guys, do consider these courses. Remember, the offer is running right now where you can get 20% off. Once you use this coupon code of SHHPRO, 20% flat off. Use this. All right. 20% flat off, SHHPRO. And where is the link? The link is in the description box below. Check out the description, read every bit, every detail of that link, and then of course you can click on that link properly and then fill up the form and join the course. But do not forget that you have to use the coupon code, or else you will not be getting the offer even if you use the link. Okay, so very, very important. All right, now let me talk about what is the main principle of Archimedes. What is the main principle of Archimedes? And that is basically your buoyant force. Now, anything which is immersed, this is what Archimedes said, anything which is immersed in a liquid experiences something called as a buoyant or an upthrust force, and this force makes that body believe that his or her weight is much lesser than when he was standing in air. So if you weigh somebody in air and if you weigh somebody in a liquid, they are completely different, and the difference comes exactly because of something called as the buoyant or the upthrust force. And this force completely depends on how much part of the body is inside the liquid, number one. It depends on the liquid also, and it also depends on the gravity. So a lot of things are going to be dependent. We'll see the formula, don't worry. But understand, this force always acts opposite to the gravity. If gravity is down, buoyant force will be up. Now imagine you take up a setup like this. You take up a block of mass 5 kg. It shows 5 kg over here. You can see this on the dial. There is some liquid over here. It has been filled till the brim. Any one bit of water extra in this beaker, it will spill out. So there is a container kept to collect that extra or the displaced water. Now what happens in this experiment is, when you dip this block, you will see whatever is the volume of this block, exactly that much volume will spill out. What did I say? Whatever is the volume of the block, exactly that much volume obviously will spill out. But whatever is the weight of the block and whatever is the weight of the displaced fluid, they may not be equal. Did you understand this? The mass of this block and the mass of this liquid which will be spilling out, they may not be equal. That's very important. So when you put it inside and now you see the reading shown by the spring balance, right now instead of 5, it is showing 3 kgs. That's interesting. Instead of 5, it is showing 3 kgs. So it has got an upthrust force of how many kgs? 2 kgs, guys. So 5 minus 3 is 2. So where did this 2 kg come from? We'll talk about it, but that is called as the buoyant force. Now the fascinating thing is, if you now measure the mass of this liquid which was spilled outside, that mass exactly happens to be 2 kgs. So that is Archimedes principle. So I'll repeat. So whenever you dip anything inside, whatever spills outside is equal in volume, but not in mass. But if you check how much is the upthrust force, that upthrust force exactly equals to the weight of the fluid which has been displaced. So this is Archimedes principle, and it says that when a body is partially, so you can keep writing this down, guys, partially or fully submerged in a liquid, just 1 second, in a liquid, then it experiences an upthrust that is called as a buoyant force, and this buoyant force is exactly equal to the weight of the displaced fluid. It's exactly equal to the weight of the displaced fluid. So if somebody asks you what is the weight of the displaced fluid, it will be mass of the fluid into G. But what is mass? Mass is density into volume. So it will be density of the fluid into volume of the fluid which spills out. But remember, whatever volume spills out is also called as the displaced volume into G. So some people also write it as density of fluid into volume which is submerged. Why? Because remember what I told you before, whatever volume is submerged is exactly the volume which is displaced. So whatever volume is submerged into G. So this becomes the formula for the buoyant force. Very important formula, guys. Okay, either this or this, whatever you want to remember. And also remember, this buoyant force always acts opposite to gravity. Very, very important. It always acts opposite to gravity. Remember all these pointers? Very important formulas, definitions and theory pointers that I am giving over here. Okay. Now Why does buoyant force come? I'll be explaining it because that is something which you would not have learned in school, and this is something which you're going to learn today. So I hope you have written down all these things. Okay, so I'm going to erase this. Get ready, guys. Now, what is exactly this buoyant force? Because all of you have this question in your head. Density, yes, noted. Okay, density means density of fluid, Dinesh. Very good, BK channel. Very good, Quincy. Very good, Aarti. All right. Thank you, Hardik. Now, what is exactly this buoyant force? Pay attention, guys. Everyone pay attention. Very, very important. You can always rewind the session back and you can always get my notes, guys. Don't worry about it. Plus, you are going to get these workbooks in the session PDF. I hope you check the description links below. In that, you get the entire session workbook. Why am I calling it as workbook? Because you can watch my lectures again in replay mode and you can again make notes, whatever problems I gave. Second thing, I have also uploaded the homework solutions of the previous sessions as well. And plus, in the description box, you have all the important things like extracts. So the chapter summary, all the important pointers also you get once the chapter is over. Not today, once the chapter is over. Remember that. Okay. Now, what is buoyant force? Now, to understand what is exactly buoyant force, just imagine some aluminium object. Just imagine an aluminium object which is immersed in a fluid. What are these black arrow marks? They are nothing but the forces due to the hydrostatic pressure. You remember hydrostatic pressure. So the any liquid under the influence of gravity experiences hydrostatic pressure. There is pressure right now everywhere. And as you go up, pressure reduces. As you go below, pressure increases. We have seen that. So at this point, the pressure is downwards because the surface is like this. Remember, pressure ka force always acts perpendicular to the area. Here, the force due to the pressure is at this angle. Here, it is like this. But notice, the arrow marks are not of the same length. Why? Because as you go below, the pressure increases. And because the pressure increases, understand even the force will increase. I hope this is clear. Okay, so they are perpendicular and they depend on the pressure at every point. So you can see they are not equal in magnitude. The ones at the bottom are very large, the ones on the top are very small. Now, if I ask you what is the resultant of all of them, okay, what is the resultant of all of them, you will be like, sir, I can understand it will be somewhere on the top, but I don't know exactly how much and I don't know what is the value of it. Alright, so I do not know how much is the value, but I know it will be on the top by symmetry. You can clearly see by symmetry it will be on the top. Is that clear? Very good, guys. Now, there is a small trick I am going to play by which I can figure out the value of this net force. You will be like, sir, how can you do that? Are you going to integrate? Guys, no, I am not going to do any integration. Without integration, I am going to get the answer. You will be like, sir, please tell me right now, I want to know. Yes, don't worry, I am going to tell you. So, instead of aluminium object, place an object which is made of the same thing as outside. If outside there is water, make it water. If there is oil, make it like oil. If there is some honey, make that object full of honey. So basically, you are having the same liquid, okay, like object, and whatever is there outside is also there inside. Basically, think you are drawing a boundary of the same shape and size as that of the solid object inside a liquid. You're just drawing a boundary, that's all. Is that clear? Now, what will happen? Yes, Advait, I'll be completing all the chapters. Now, once you draw this boundary, just understand one simple thing. The forces which are acting at all these points will still be the same. Why? Because you are still at the same depths at each point. This force will not change. This force will not change. This force will not change. This force won't change. All the points will have the same forces. So don't you see that the resultant of all these forces here and the resultant of all these forces here should not change? Isn't that correct? The resultant won't change. Now you'll be like, okay, you still haven't solved the problem. The question still remains that I want to find the resultant of all of them. No problem. Now think about it. In water, will it sink or will it float or will it stay there? In oil, will it sink, will it float, or will it stay there? Obviously, the same liquid will stay there as it is. It will neither go up nor will it come down. That means, if you draw the free body diagram of this part, understand whatever is the resultant of these forces, it will be upwards. That force is called as the buoyant force. What did I just say? The resultant of all these forces, these teeny mini forces, is called as, first of all, buoyant force. And since this liquid stays there, that means this buoyant force should exactly be equal to the weight of fluid in this much part. Why? Because this part is neither going up nor coming down. So whatever is the weight of the fluid in this part, shouldn't it be exactly equal to the resultant of all these forces, which I'm representing by FB or buoyant force? Yes, is it clear everyone till this point? Is it clear everyone till this point? No, Advait, not by December end, by January end or February first week, before JEE Mains, before your board examinations, don't worry. Now, if this is clear, think about it. This resultant force should be the same resultant force that acts on aluminium. Shouldn't it be the same resultant force that acts on aluminium? Think about it, because the teeny mini forces, pressure forces are still the same. But what will be different? What will be different? Inside, what is there is different. Here it was water, here you have aluminium. So aluminium may not have the same weight as that of this force. Why? Because water in this volume has different mass, aluminium in the same volume has a different mass. But the resultant of all these forces is same, as if there is liquid inside. So should I tell you a trick? The trick is, the resultant of all these forces is such that they feel that there is water inside and they have to support the weight of the water. So they apply the force thinking that there is water inside, but they may get fooled because there could be anything inside. So buoyant force is the resultant of all the pressure forces, hydrostatic pressure forces from all the sides, thinking that there is water in that same volume. Now, the moment, if you have understood this point, yes, if you have understood this point, understand, if this mass is more than the water's mass, okay, if this mass is more than the water's mass, what will happen? This weight will be more. Buoyant force still thinks there is water inside, so it will apply only that much force, but actual mass is more. So what will happen? The object will sink. Is that clear? The object will sink. Yes, the force gets misunderstood. Excellent words, Princey. But if the same mass is less, that is, the density of that object is less, then this weight will be less. Then this weight will be less and the buoyant force will be more, so that object will go up. Understand, the buoyant force always thinks that there is water inside. Understood? This is how it happens. Now, whether you put aluminium or whether you put any other body, doesn't matter. Whether you put lead, whether you put cork, whether you put anything, the forces remain the same. So the buoyant force on all of them will always be the same, but what will be different is the weight of the solids. So if the weight of the solid is more than the buoyant force, it sinks, and if the weight of the solid is less and buoyant force is more, then the object goes up. And if they are equal by chance, and when will that happen? When the density of the liquid and the solid is the same, then it will neither go up nor it will come down, just like in this case. I hope this is clear. Now you will never forget it. Krito, understand, even if the material goes inside, even if the object goes inside, all vectors will increase. All vectors will increase. So the buoyant force will still remain the same. Understand that. Jumna, that reason is biological. Alright, that is because air enters inside and all that. Okay, I understand that. Alright, I hope everybody is clear. And now let's do some problems. So let's do a question on sinking object. So when an object sinks, just one second. So when an object sinks, what exactly is happening? Understand that the weight of the solid and the buoyant force, which is Fb, they are not the same. That is why it will sink and it will accelerate down. So in fact, when an object sinks, the density of solid is more than density of fluid, and I can say, using Newton's laws, weight of solid minus the buoyant force is equal to mass into acceleration. Is that clear? That is what I can write. So what is the weight of the solid? Well, the weight of the solid is mass of the solid, okay, the same mass m, into g. And what is the buoyant force? We just discussed. It is the volume submerged, which is the total volume, into rho, which is rho of the fluid, okay, rho of the fluid, into g. Now this is equal to ma. Please understand, this m is the mass of solid only. Now what can you write mass as? Mass is density into volume. So what is the mass of that block? Density of that block, which is the density of solid, okay, density of solid, okay, into the volume of that block, into g, minus v into rho of fluid into g, is equal to mass of that block is again density of solid into volume into a. Now see, what and all will get cancelled. I think v will get cancelled. G can be taken out common. So I'll get rho of solid minus rho of fluid multiplied by g, and that thing over here I can just write rho of solid into a. And if you want to find the acceleration, you can just bring that solid part below and you'll get 1 minus rho of fluid by rho of solid, the entire thing, into g. So this will be the acceleration. Clearly it is not g. So when you drop some object, the acceleration with which it sinks is completely different than g because of the buoyant force. Keep this in mind. Don't by heart this formula, but I have just shown you how to solve problems. Understand problem solving techniques. This is how to apply the theory what you have just learned. Bhargav, surely I will respond to you, surely. Don't worry. Yes, mass is again taken out. Okay. I hope this is clear. Yes, Selva, you said it correctly. Buoyant force blindly believes that it only sees water. Okay. Now the next thing, floating objects. Now there is one very important thing that I am going to give you over here as well. I hope you guys are making notes. Very good. Princey is making notes. Excellent. I hope others are also making notes. Now when an object floats, the density of that solid is less than density of that fluid, guys. Okay, and a part of it only is submerged, a part of it is outside. So let's just say that, you know, this is the volume submerged, but V is the total volume. So this is total volume, and Vs is nothing but this is the volume which is submerged. Now you can easily find that. It's not that difficult at all. How? First draw the free body diagram. Think what will be the forces on the block. One will be the own weight of that block. Correct? So the own weight of that block, and the next force will be the buoyant force. Guys, think and tell me what will be the acceleration when this object is floating. It is just floating there. What will be the acceleration of that block? Come on, and where will it be? Will it be up, will it be down, or will it not be there? Yes, correct, Kirito. Yes, Uncharted. Very good, excellent. No, Saurav. Floating means it can be either of these things. Either it can be like this, or either it can be like this, or either it can be like this. All these are floating objects. Okay? Floating does not mean the densities have to be equal. Please understand that. Okay, in fact it can be less than or equal to. Either of them is possible. Okay, be careful. I hope Saurabh this is understood. So now, yes, the acceleration is 0 because It is floating. So it is just staying there at rest. So think about it. In this case, the buoyant force will be equal to the weight of that block. And what is the buoyant force? Buoyant force is volume submerged into density of fluid into G. And what is the weight of the block? It is mass of the block into G. But mass, can I not write it as, volume, total volume into density of that block? Or I can just say density of the solid. So density of solid into G. Best part, G goes away. And what will happen? I will get volume submerged upon total volume is nothing but density of solid upon density of liquid. Now this is very important. You should know this. Volume submerged upon total volume is density of solid upon density of liquid. You should know that. Now why you should know that? Hello Chandan, welcome, join in. It makes your life easy, guys. I'll tell you how. Imagine that, okay, I'm just removing all this now. It's not needed. Imagine if I tell you there is a wooden block of density 800 and it is floating in water whose density is 1000. Then how much part is up, how much part is below water? Very simple. Just do 800 by 1000. How much is 800 by 1000, guys? It is nothing but 80%. Think about it, it is 80%. But what is 80%, guys? This is the volume which is submerged, is 80% of total volume. So you can directly give me the answer. That is very important. So just note down the fraction. So the densities ratio give me exactly the fraction of submerged upon total volume. Very important for solving problems. So sometimes they can give you that block's length is, I don't know, maybe 10 meters or something. So that means 80% is submerged. So that means 8 meters is inside the water and only 2 meters is outside. You can directly do that. Okay, so remember this. Yes. And that is the reason why they say tip of the iceberg. So when you see an iceberg, what a beautiful picture. Just appreciate this picture, guys. This is only 10% and this much is 90%. If that's the case, can you think what should be the density of ice upon density of water? Think about it. What is the density of ice upon density of water? It should be exactly submerged upon total. How much is submerged? 90%. So the fraction should be 9 by 10. Think about it. Not 1:10. Submerged upon total. Be careful. So that's why, Kirito, it's not 1:10. 9 by 10. So remember this. I hope this is clear now. Understood, everyone? Is this clear? So remember this diagram. This will be helping you solve problems now. That is the trick I gave you. Ratio of densities and ratio of submerged upon total volume. Very, very important. Excellent, guys. Excellent. And if you are loving all this, do not forget to smash that like button down there. Yes, please do that. Smash that like button because there are a lot of problems coming up. Come on. Do that if you are not yet done. And if you are a new user, you know what to do. You should go hit the subscribe button down there because or else you'll miss out all the important lectures. Okay, so now let's do this question. A cylinder of brass. Somebody was asking, sir, will steel weigh less in liquid? Yes, you will see why. Weighs 60 grams in air and the density of brass is so and so. The weight of the cylinder in water is how much? Come on, let's see. I'll just give you a minute today. Okay, and let's see if somebody can give me the answer. Come on, guys. Starting the question. Oops, I started a stopwatch. Come on. Let's see if somebody can give me the answer. All right, Princey, thank you. If you smash 2 times, then it will go to unlike, I think, or you will probably not like it, Princey. All right. Sir, 9 by 1, no, sir. Dinesh, I didn't quite get what you are saying. Come on, guys. If somebody has the answer to this, please let me know. Come on, quickly. Acha, Princey, by 2 accounts. Okay, glad. Wow, very good, VK channel. You are answering fast. Jumna is also answering fast. Krito, very good. Let's see whether A is correct or wrong. Don't worry, we'll see. So should you know that ratio 9:1? Yes, you should know that. It's a standard value. So you should know that ice is 90% as heavy as water. Okay, the time is up and the correct answer is option A. And now let me tell you why the correct answer is option A. See guys, if you draw the free body diagram of a cylinder inside a liquid, you will get the answer. What is the weight of the cylinder inside water? This is the green color thing is the weighing machine. So there will be a normal force by the weighing machine on the cylinder. Then there will be the weight of the cylinder. And do not forget, of course, there will be also a buoyant force on the cylinder. So these are the only three forces, and acceleration of course is 0. Now keeping all this in mind, let's start solving the problem. Normal force plus the buoyant force is equal to the weight. Therefore, so remember, the question is what is the weight of the cylinder in water? The meaning of this question is what is the normal force? Okay, so you can convert it into any units that you want, but the question demands us to find the normal force. So normal will be weight. Now what is the weight? 60 grams, correct? So grams in kgs, you convert it 60 into 10 to the power minus 3 into 10. So that's the weight, and minus buoyant force. Now buoyant force will be volume submerged into density of liquid. Now water's density is 1000. So I'll put 10 to the power 3 into G. Okay, V rho G. But what is that volume? We'll figure that out, don't worry. So this will first of all become 6 into 10 to the power minus 1 minus. Okay, now what is volume? Volume, because density is mass by volume. So volume will be mass by density. So mass is already given, 60 grams. So 60 into 10 to the power minus 3, okay, by density, which is 5 grams per cc. So convert it into kg per meter cube, which will be 5 into 10 to the power 3, I believe, into that 10 to the power 3 into G. I'm just showing you the systematic way, guys. That's all. Now, if somebody wanted, they could have done one interesting thing. They could have just taken out, just keep all these things as G only. Just leave it as G. It will be simpler for the calculations. So just bring it outside. 6 into 10 to the power minus 3 G. 1 minus, check this out, 1 minus, so many terms have been taken outside. Okay, so I think 10 to the power 3, 10 to the power 3 goes, you'll have 1 by 5 over here. So 1 minus 1 by 5 is 4 by 5. So 4/5 of 60, well, that is 48. So 48 into 10 to the power minus 3 G, which is same as 48 grams. That is the answer. Yes, that's it. That is the answer. This 10 to the power minus 3 converted it into kg. Into G made it into Newton. So I don't want the answer in Newton because the options were in grams. So that's why I converted into grams, guys. So I don't need that factor of 10 to the power minus 3. That's the shortcut. And G is going to convert it into force, newtons. But mass is in kgs or grams. So that's why I've done that. Alright? Understood, everyone? So this is how you get it. Now, do you see the actual weight was 60 grams? 48 grams is the one which you measure it in water. So what is the loss? 12 grams. 12 grams is lost in water. Who is responsible? Water. So water's weight which was displaced is exactly 12 grams. So 12 grams of fluid or water was displaced. That's why that reduction in that. Understood? Excellente, guys. Excellente. All right. So let's get going, guys, to the next question, which is coming up on your screen now. So let's talk about Dead Sea. Now, I don't know how many of you have heard things about Dead Sea. The fascinating thing about Dead Sea is that in normal seawater, the salinity increases the density, and that's why floating becomes easier in saline water than in fresh water. Now, for Dead Sea, the salinity, because of the minerals and the dissolved salts, is so high that you can very easily float, and a lot of tourists go there, relax with a sandwich, with a juice, with a newspaper, they read, and they can float easily. You cannot drown in Dead Sea. That salinity is so high. Look at this cool dude out here, how coolly he's enjoying whatever he's reading or seeing or painting or drawing. Yes, Ankit, I just mentioned, right? Steel will weigh, I mean the brass question, I hope you are reading that. Yeah, I just mentioned about it, Ankit. You know? So that's the speciality of Dead Sea, guys. Now, we'll solve the question on Dead Sea. Let's see if we can do that. A Pandu is floating in 3 different scenarios. Scenario 1, Dead Sea. Scenario 2, Arabian Sea. Scenario 3, freshwater pool. What would be the order of increasing buoyant force on him? So if he's floating in all these 3 things, what would be the increasing order of buoyant force on him? Come on, guys. No, Aishwarya, you cannot walk on water. It's not so high also. Okay. 1, 2, 3, 3, 2, 1. Okay. Lot of people are giving different answers. Arabian Sea is normal sea, the one which is there on the west coast of India. Come on, guys. Okay, now should I tell you the answer? Come on, guys. Come on. No, Ankit, obviously no, you cannot walk. It's not so high. I just told, right, Ankit? You are asking the same doubt again, Ankit. Okay, you cannot walk. Okay, so guys, the correct answer is all 3 are equal. Yeah, you guys got it wrong. Think about it. That Pandu which is there, who will be floating in that water, there are only 2 forces acting on him. One is the weight, second is the buoyant force. And he's floating. If he's floating, that means acceleration is 0. And if acceleration is 0, buoyant force is just going to be equal to the weight. And whose weight is this? This is Pandu's weight. So where is Pandu's weight more? Everywhere it is the same. Pandu weighs the same in all the 3 scenarios. So buoyant force is the same. So we're like, what the hell, sir? Density was different. What did you just say now? Guys, the volume submerged will be different. In Dead Sea, the volume submerged is less. Understand that. This buoyant force was rho of the fluid into volume submerged into G, right? So wherever density was more, volume submerged will be less. So understand, volumes were not equal when it was submerged. Understood? What a tricky question it was. Little नहीं, बहुत ज़्यादा misunderstanding हो गया. All right. Yes, Bhavna, look at that. Okay, guys, let's head to the next question. What a fascinating question this was. Let's get going. Now, what will happen to the level of water in glass when ice melts? What do you think should happen? Okay. What will happen to the level of water when ice melts? Now, let's discuss this question because not many people truly understand and they do some stupid derivations using some formulas, many books. Guys, it's not needed. Understand the logic, and that's what I'm going to tell you. Because there are different ways of looking at it. If you just study books now, you'll always think, oh, it's complicated, and you'll memorize certain derivations and this and that. Understand the logic, and today I'll tell you the logic behind this. See, okay, this is our container, and let's say this is our block of ice, and let's say this is the level till which the water is there and the ice is floating on it. Now, here is what we are going to do. Just imagine a scenario where that ice is removed but that cavity remains. So it will look something like this. It will look something like this. So that cavity basically tells me how much fluid was displaced. So now imagine if I exactly take out this much volume of fluid, or if I pour this much volume of fluid in this cavity, or rather this much part, exactly tells me the volume of water which has been displaced. This is exactly the volume of water which has been displaced in this much part. Everybody understanding it till here? Okay, don't worry guys, some of you are saying increase, some of you are saying decrease, some of you are saying it remains same. Now observe this. This is exactly the volume of water which was displaced. Now think guys, this ice which was there, okay, this ice which was there, if I allow it to melt, it will become water or a liquid form. It will definitely convert itself into water. It will convert itself into water. Now all that you need to do is just check if this much water exactly fits into this, or is it more than that, or is it less than that. Did you understand the trick guys? What we have to do? We have to check whether this much water exactly fits into this, or is it more or is it less. If it is exactly same, that means the level of water will not change. And if it is more, that means the level of water will increase. And if it is less, then the level of water will decrease. Understood this concept? Now let's see who is more, who is less. Guys, when it was floating, can't I say that when it was floating, there were two forces. One was the buoyant force and one was the weight of ice. And weren't these two equal? Isn't it? Think about it. And now think, what is buoyant force equal to? Buoyant force, guys, isn't it equal to the weight of this fluid? Isn't buoyant force equal to the weight of this water which was spilled outside? Isn't it? And what is the weight of that ice? Isn't it the same as the weight of the water? Isn't it the same as the weight of the water? Now here is the logic. Fb equals to weight of ice. Weight of ice, obviously the mass remains the same, is also equal to the weight of this water. A equals to B, B equals to C, and A also equals to D. So obviously A, B, C, D all are equal to each other. So what does it mean? The weight of this melted water, isn't it the same as this green colored water, which is the volume of the fluid displaced, the displaced fluid? Aren't these two weights equal? If these two weights are equal, what does it mean? Their volumes are also same. That means this will exactly fit over here. So the water level will neither go up nor come down. Yes, it remains the same. So what is the trick? The trick is, remember, always take out that object, see that empty cavity. Now think, in that empty cavity a fluid would be present, and then think whatever object was there, if it does whatever it has to do, melts, freezes, God knows what, then check its weight. And now compare their volumes. If their volumes are same, then the level will neither go up nor come down. That's all you need to do. So the answer is, it remains the same. That's how you need to solve it. Did I write even one equation apart from this stupid equal to? One equation, one derivation, nothing. Just pure logically I have got the answer, guys. Hello Gaurav, join in. Okay, so let's get going to the next question now. Okay, this is also a very good question. What amount of total volume of the floating solid is inside each liquid? What volume is inside each liquid? Now there are two liquids. This green colored liquid is less dense, blue colored liquid is more dense, and this solid is somewhere between the green and the blue liquid. So it is not even sinking inside the blue one because it is lighter than the blue one, but it is heavier than the green one. So it has been stuck somewhere in between. So how much part is there in each liquid? Now this is a common question which is asked, and we need to know how to solve this. First thing, assume that the volume submerged in that green part is, let's say, V1, and the volume submerged in the blue part, let's say it is V2. So what is V1 and V2? They are the volumes of the cylinder or that object submerged in each of that liquid. Now why is it important? Because think, each volume submerged will give rise to a buoyant force. So buoyant force 1, and there will be a buoyant force 2. Buoyant force by upper liquid, buoyant force by liquid below, and these two buoyant forces are holding the weight of that entire solid. So the weight has to act downward, obviously. So weight is down, both the buoyant forces are holding up that liquid. Yes. So now what will happen? FB1 plus FB2 is equal to the weight, guys. And what is FB1? Volume submerged in that liquid into density of that liquid into G, plus buoyant force 2 will be volume submerged in that liquid into density of that liquid into G. Weight of the solid will be mass into G, but what is mass? Density of that body. What is the density? 2 rho into total volume. Please understand, this is nothing but mass of that solid, and that V was the total volume into G. What will happen? G goes, rho goes. So what will I get? V1 plus 3V2 is equal to 2V. This is equation 1. But hold on, I know one more thing. V1 and V2 together give me total volume. So that is my second equation. So V1 plus V2 is the total volume. So that is equation number 2. So what do I do next? Think about it. Just subtract the 2. So 1 minus 2. V1 will go. 3V2 minus V2 will be 2V2. 2V minus V is just V. Therefore, V2 is just V by 2. Now if V2 is V by 2, obviously V1 will also be V by 2. So I have found out what is the final answer. I hope this is clear. Now you will be able to solve all kinds of problems in JEE. These kind of questions were very common in BITS, in CETs, in KVPY, all the examinations. This question was common, half and half. Now if any other values are given, the method remains the same, only these values will change, that's all. So you now know how to solve the problem, you have learned the technique. Got it? Very good, very good. Hello Shreyas, join in. How are you? Okay, so let's get going to the next question. Now before going to the next question, I'm going to tell you why ships float. Okay, so some very good questions are coming. Hello SK. Now, why do ships float? For that, let's talk about something called a center of buoyancy, and I'm going to give you a brilliant question on that, guys. Now, what is this center of buoyancy? To understand that, remember that explanation I gave you for buoyant force. All the forces of pressure act from everywhere. The resultant of all those forces can be found by replacing that aluminum with same liquid which was present outside. Then the resultant will exactly balance the weight of the fluid, correct? Will balance the weight of the fluid. Now, where do you think this buoyant force actually should act from? Should it act from here, 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 etc.? The answer is, it acts exactly from the center of mass of this liquid. Where does it act? It acts from the center of mass of this liquid. You'll be like, sir, why? Why can't it act from two different places? Let's assume that the forces are not at the same place but are separated by some distance. If these two forces are equal but they are opposite, what will it create? It will create a torque, and once it creates a torque, this liquid is rotating. And if this liquid starts rotating, guys, this is no longer a statics problem. The fluid is not stationary. So for a stationary fluid, remember the torque should not be there. So that force should act from the center of mass of the fluid. Is that clear, everyone? So now, if that is clear, think about it. The resultant on the aluminium will act from the center of mass of the liquid inside it, had there been a liquid. But does that mean the weight of aluminium should be also at the same place? No, it could be at some other place, and in fact that creates the difference. Understand that. So this point, understand, is the center of mass of the solid, or I can say the object. But this green point that you see over there, this is center of mass of displaced. Oh, I did it completely ulta. I'm so sorry, guys. One second. I'm so sorry. This was the center of mass. So sorry. This was the center of mass of the solid. I'm so sorry. Or the object. And this black one, this was the center of mass of the fluid. So center of mass of the displaced fluid. This a point where the buoyant force actually acts from, that is called as center of buoyancy. Center of buoyancy. So this green dot over here is the center of mass of the solid. It could be anywhere. Maybe it's not a uniform solid. Maybe if there is more aluminium here, there is less aluminium there. Maybe there is a cavity in that aluminium. Doesn't matter. But center of mass and center of buoyancy need not be at the same place. That's what you should understand. I hope this is clear, everyone. Everyone understood it? Navni, no problem. Join in. It's okay. Now, based on this, you have the whole concept. Hello, Asmi, join in. The whole concept of how ships float or how they remain stable. Now, look at this. For a good ship to exist so that it does not sink, the center of buoyancy and the center of mass should be such that, imagine that point B over there, okay, represents center of buoyancy. That point G represents center of mass of that ship. Center of mass is above the center of buoyancy. So that green pen over here, downwards, is basically the weight, and this blue pen over here is nothing but the buoyant force. Remember, the weight is on the top, the buoyant force will act from below. So this is how it should look like. Now, if the ship tilts for some reason, you will see that there will be a torque which will be created. Think about it. If the ship tilts for some reason, there will be a torque which will be created, and that torque, think about it, it will tilt the ship even more. Yes, Kirito, I said buoyant force will act from the center of mass, but center of mass of whom? Center of mass of the displaced fluid. The displaced fluid center of mass and the object center of mass can be two different places. Understand that. So buoyant force acts from center of mass of displaced fluid. The weight of the solid could be somewhere else. That is the difference. SK, this is an English channel. I cannot explain in Hindi. For Hindi, you can go to other places, okay? This channel is only in English. Please understand. All right. Excellent, Kirito. All right. So now my point is that the center of gravity is on the top, the center of buoyancy is below. So if the ship tilts, what will be the torque doing? The torque will be toppling it over. Think about it. The torque will topple it over if the center of, if the ship tilts, then what will happen? The buoyant force will shift over there. The center of gravity will be over here. Then what will happen to that torque? The torque will restore it back. Look at that. The ship tilts slightly over here. The gravity is acting from here. The buoyant force is slightly over there. All right. Think about it. The ship tilts. So what will that torque do? The torque will try to restore it back. So this is what you would want. If the ship tilts, the torque brings it back. Yes. So that is the whole concept in a ship, that whenever a ship tilts, the buoyant force and the gravity produce a torque in such a way that the ship is restored back to the original place. That's what happens. Okay, now let's do a question based on this. Very interesting question. There is a rod which is hinged at the bottom of a bed, and the river or that lake or that pond has a height of L by 2, where L is the length of the rod. Now that rod's density is only half the density of the liquid. That means the rod wants to float, but it is also hinged at the bottom. So the rod is maintaining a kind of an equilibrium somewhere, and the question is, find the angle which it makes with the vertical. That's the question. All right. So let's do this question if everybody has understood the diagram. So what happens? Now this is a very good question to explain center of buoyancy, that's why I'm taking this up. The rod has a length L. So the rod's weight will act from the center of mass of the rod, somewhere here, exactly at half the length. This is the weight of the rod. But the buoyant force will not act from here. Why? Think about it. Only this much part is under the fluid, correct? So what is the displaced fluid? The displaced fluid is only this much part. I hope you can see that. So the center of mass of this much part, only this much, will be somewhere here, not there. So the buoyant force will act exactly from that point and not from here. So that is the catch. Let's see. I don't know. It's a complete guess. So now, if you have understood this, let's proceed. But let me also tell you, because it is hinged, the hinge might also give some normal reaction, which we do not know how much it is. So I'm just showing it over there, just to be on the safer side. Okay. Now, let me mark those forces. This is the normal by the hinge. This is the buoyant force, and this is the weight. Now, should I balance the forces or should I balance the torque? Which method do you suggest? Which method do we suggest? Which method do you guys suggest? Torque? Yes, because I don't know the value of normal. So let's do it by torque. Now for torque, I first of all need to know the value of the forces. So let's just figure out what is the value of buoyant force. Now to do that, I'll do one more thing. Let's assume that from this point, all right, let's say I call it, let's say D, let's say this is E, and let's say this is A. So this length AD, okay, this length AD, let's say I call it X. This much is X. So what is the buoyant force? The buoyant force will be volume submerged into rho of the fluid. Now what I will do is, since the density of that object is half the density of the fluid, what I will do is, let's assume that the rod's density is rho and the liquid's density is 2 rho. Makes sense? The liquid's density is 2 rho, rod's density is rho. That's what I have done. So V submerged into 2 rho into G will be the buoyant force. But how much is the volume submerged? Simple. Let's say the area of the rod, cross section. That rod will have some cross sectional area. If this is the rod, there will be some cross sectional area. So let's assume that as A into X. Why X? Because the length AD is nothing but assumed to be X into 2 rho into G. So that is the buoyant force. I hope this is clear. I hope this is clear. Is that okay, guys? How much is the value of buoyant force? Now think, what is the weight of the entire rod? The weight of the rod will be density of the rod, okay, density of the rod, rho, into area of cross section into the total length, because this much is nothing but the mass of the rod into G. So density into volume will be the mass, into G will give me the weight. So I have got all these things. Now the only thing remaining is to figure out the torque. How much is this length? So let me also mark that point. Let's say DEF. How much will be AF? Length AF will be exactly X by 2. Check this out. If AD is X, F will be at the midpoint, because that's where the center of mass is. Please understand, this is where the center of buoyancy, or I can say the center of mass of the displaced fluid is. So that is center of buoyancy. Remember that. Now this F is at x by 2. Now what you are going to do, guys, I'm just going to extend this line a little bit over here and just think how much is this length. I will be needing it. Why? Because to calculate torque, what did we do? Perpendicular distance into the force. R perpendicular into force gives me the torque. So that's why I will be needing that distance. Think about it. So let me mark this as F1. Okay, if this is F, this is F1. Similarly, if I extend the line of weight, all right, this distance, let me call it as something else, maybe some other point, F, and this was, let's say, G. So this will be G1. Think about it. I hope this is clear. In case you are still not able to see it, this is G1. Is everybody understanding it till this point? All right. So now think, whose torque balances whose torque? The torque by the buoyant force will be, which is like that, will be balanced by the torque by the weight clockwise. So these two torques are in the opposite direction and they will balance each other. So what is the torque by the buoyant force? It will be this distance, which is AF1 into the buoyant force itself. Okay, AF into the buoyant force itself, and the torque by the weight will be AG1 into the weight itself. Now just start substituting values. What will be AF1? AF1 will be AF sine theta, I believe. If I take this angle as theta, then this is also theta, this is also theta. So AF1 will be this much sine theta. How much is AF? AF is x by 2. So it will be x by 2 sine theta. And what is the buoyant force? I just figured it out, which was AX2 rho g. That was the value of the buoyant force from here. Next, AG1. What is AG1? Think about it. It will be this distance sine theta. This is the hypotenuse. And what is AG? AG is nothing but, think about it, L by 2. Because if this is L, G is at the center of mass. So it is nothing but L by 2 sine theta. Now I'll erase all this, not needed. Into weight. What is weight? Rho A L into G. Now see what and all will get cancelled. Oh, sine and sine gets cancelled. A gets cancelled, rho gets cancelled, G gets cancelled, 2 gets cancelled. So I just have x square is equal to, just check this out, I think only 1 2 is there. 2x square is equal to L square. Therefore x is nothing but L by root 2. This is what I got. X is equal to L by root 2. Buoyant force will always act opposite to gravity. Please keep that in mind. Okay. So now once I get this, just think about it. In this triangle, okay, in the triangle that you have, so that was A and this was D, and this point something, let's say it was L by 2 at a distance of L by 2, because this is given to be L by 2. I already know what is AD. AD is nothing but L by root 2. So how much will this angle be? Think about it. Think about it. This angle will be 45 degrees. That's it. That's how you get the answer. So this is a proper advanced level question, guys, based on buoyant force, center of buoyancy and other things. If A to D was X, A to this point was L by 2, so this angle obviously has to be 45 degrees. Understood, everyone? Excellent. Shall I erase? Shall I go ahead? Come on guys, I'm waiting for you. Yes. Now, before we go ahead, let me tell you about balloons and apples. Yes, your guess was correct only because I had chosen some values. If the density was not 0.5 or something else, the answer will be completely wrong. So I have told you the method now. Okay. So guys, you know what is my intention of doing those kind of difficult problems? just to make sure that guys never give up. No matter how difficult the problem looks like, you should continue. You should continue till the end, till you get the answer. Only then you will feel confident. That's why I end up solving everything. I could have just told, okay, now solve the equations, you will get the answer. That's what is done in many coachings also. Okay? So, but since I'm teaching you over here, that's why I'm solving till the end, to make sure that you understand every step and that it is achievable, no matter how hard that problem looks like. Now, let's talk about balloons. Now, balloons go up because the buoyant force is much higher than the weight of the balloon. Similarly, apple falls down because the weight of the apple is much more than the buoyant force on the apple. That's obvious. So, let's use this concept and see what happens in a train. There is a train which is accelerating, and there is a balloon over here, and there is also an apple over here. Both of them are released in that accelerating train. What do you think will happen? Which direction approximately do you think this balloon will move and apple will move? Where do you think each of them will move? Yes, Dinesh, I'm sweating. What to do here? Suddenly it has again become hot, so that's why I stopped wearing sweatshirt. It's become fine now in Bangalore. Earlier it was very cold. Now it's become a little bit warm only. So I've stopped wearing my sweatshirt also. Come on, come on, come on, guys. Where do you think the apple will go? Where do you think the balloon will go? Balloon is 2, apple is 4, 6 and 2, 6. The train is moving towards the right side. Oh, I didn't mention that? Okay, the train is moving towards your right side. Chalo. The train is moving towards your right side. Accelerating towards that side. Direction 3. Okay, okay. 2 and 4, 2 and 6. Think. Okay, time is up then. So the logic goes like this. If the train accelerates there, then what happens is, there are two kinds of gravity. One is your actual gravity. Second is the gravity created because of that pseudo force. So actual gravity here, the pseudo gravity over there. So what will happen? The effective gravity, G effective, will be here, somewhere like this. It's understood. Mg is down, pseudo force is here, so net force will be somewhere here. So because of that, what will happen? The apple will go like this, but the balloon will go opposite to the effective gravity. So this is what will happen. Very interesting. The train is accelerating forward, but the balloon will not go back. It will in fact go forward. Isn't it surprising? And this is what exactly will happen. Exactly, that's what will happen. The apple will fall back. This is normal. This is what you're used to seeing. Yes, if you drop an apple, because the train was accelerating, so instead of falling down, it will fall behind. That's okay. That's understood. That's quite convincing. The balloon goes up there, not back. That is what is interesting. Next time you're in a metro, you can do that. Just don't look stupid. That's all. But it's okay, even if you look stupid, you are doing it for physics and for science. Yes. Now, this concept can be also used for moving fluids. A container in which there is a fluid, and because the container accelerates, you will see the angle at which the surface is slightly inclined. And guess what? You can solve the problem using the concept of effective gravity. So the actual gravity, G, was down, but the pseudo gravity was backwards. This is because of the pseudo force. This is the actual gravity. So what will happen, guys? You will see that the resultant, which will be G effective, will be like this. And if I say this is theta, that's the angle which is made. So tan theta will be A by G. So that's the angle at which G effective will be. And you will see that the surface of the liquid will be such that it will be perpendicular to the G effective. It's always true. When you leave water to lie down on whatever in a container, you will see gravity is down, surface of the liquid is flat. But if the container accelerates, then the gravity perceived by that container changes. So the perceived or the effective gravity is here, so the surface also tilts to maintain its perpendicularity with effective gravity. That's what will happen. So if G has tilted by angle theta, think about it. If my thumb was down, if my pointing finger was horizontal, rotate my thumb by theta, my pointing finger also rotates by theta. So you will see that the surface has tilted by theta. So that theta will be tan inverse of A by G. That's how you solve the problems. That's how you solve the problems. Very interesting. Alright, so remember this, very important. And let me tell you one last thing here. The isobars, remember I have shown you isobars? The points of the same pressure when joined, those are called as isobars. Usually they were horizontal, but in an accelerating fluid, they are not horizontal, they are at an angle. Be careful. Yes, what did I tell you yesterday in my previous session? That G always acts perpendicular to the isobars. So these are the isobars. Please understand. This is P1 isobar, this is P2 isobar, this is P3 isobar. Understand, P3 will be more than P2 and P2 will be more than P1. That's how it will work. G will always go towards more and more, higher and higher isobars. Remember that. So let me tell you the stars of the electricity, current electricity chapter. Some of you had posted the answers. Very good Ranjit, very good NVD, very good Dinesh for posting the answers. So guys, I'm going to post all the people who are going to put up the answers in the comment section. Excellent guys. Even if your answers are wrong, it's okay, but you are the stars because you are trying it out after the session. So today's homework is this one. Note it down. You can take a screenshot. I'll just move away from the screen. Take a screenshot. So uncharted, that balloon in the train, what happens? The buoyant force is more than the weight. So that's why the buoyant force takes over the weight and that's why it moves forward. Alright, so I'll be posting up the answers as well as the solution in our Telegram group. This is our Telegram group. The link is in the description box below. Do not forget to check it out. And remember, there is also a crash course running for all the dropper and the 12th standard students. And you can check out the link in the description. The coupon code is SHCC so that you can get 2,000 rupees flat off on 10,000 rupees. So the course price is 8,000. Check out all the details in the description for all the droppers and the 12th standard student. So I hope you have enjoyed the session, and if you have enjoyed the session, you know what to do. Just like it, and if you are new, please hit the subscribe button so that you can attend all the sessions and do not miss out on any of their sessions. Thank you guys very much. What a lovely session it was. Tomorrow I will see you guys again at 7 p.m. I'll be also posting the answer of the quiz I asked on Instagram. I'll be also telling you when I'll be going live on Instagram very soon. So stay tuned, stay updated, and also study well, solve the homework question and post the answers below. Bye bye, tada. This was Shreyas here, your master teacher. Bye bye.